Hello guys, welcome back to the VDC space. Today we're going to be doing generative design in Revit. So it's going to be a very much interesting episode. We're just going to keep it as basic as we can. So the workflow will consist of loading in solar panel families into our project, and then we're going to create a study, and then we're going to apply generative design when it comes to that. So the solar panel family is I downloaded it from Beam Object, so I will leave the link in the description. And then after that, we're gonna model just basic walls and then apply a concrete flat roof on top of those walls along with the parapets. And then use the rooms we're gonna use the room separator and then the room tag in order for us to generate sort of like perimeter and area for that roof, and then we're gonna apply generative design to that. So there are different use cases when it comes to generative design. You can use it for sustainability planning, uh, and also quantification, because it multiplies different elements based on how you set it up. So you can take it also further by creating your own studies beyond what Autodesk has offered by using Dynamo scripts, which then feed into your studies, and then you can create your own different configurations and your own constraints. And also you can use Python, I think, which then feeds into Dynamo, which then feeds into your generative design study. So before I get started, I would like to ask you guys to please subscribe to the channel if you are new. If you already subscribed, hit that notification button as I upload BIM modeling tutorials and Revit tutorials 3 times every week. I cover different topics from wastewater, structural engineering, architecture, roads and earthworks, bridges, aviation, and so on. So without further ado, let's jump into our project. So here we are in Revit. I just open up the construction template. So we have two levels, level 0 and 1. So the first thing is I'm just going to go to wall, and then I'm just going to model my wall. So I'm going to take it down by 10,000 millimeters, and then to the right by 5,000, and then down by 10,000, and then to the right by 15,000, and then 10,000 again. And then I'm going to take it to the right by 8,000, and then up by 10,000, and then so it's going to be 28,000. So I'm just going to join them like this. Press escape, and then I'm going to go to level 1, which is the top level. So I'm going to go to structure and say floor, and then on my floor I'm going to go with pick lines. So I'm just going to pick these middle I'm just gonna pick on the middle of these walls like this. So this is what we have. Now I'm gonna say finish, and then when I open up the 3D view, this is basically what we have. So I'm just gonna select all these walls, and then I'm gonna set the top constraints to level 1, and then the top offset to 1000 millimeters for our parapets. So I'm gonna go back to level 1. I'm just gonna remove this span annotation, and then I'm gonna go to architecture and say room separator. So I'm gonna say pick lines again, and then I'm gonna pick the inside of these walls to apply our room separators, and then press escape. After that, I'm gonna go to room, and then I'm gonna apply my room tag so that you can see the area of your roof slab. So this is what we have, 416 square meters. And then this is basically our setup. So I'm gonna go to insert and say load family. So I'm gonna load in my solar panel family. So it's this one, Ryzen Solar Pack Solar. So you can get it from Beam Object. I'm just gonna say open, and then I'm gonna say architecture, and then say component, and then I'm just gonna place it like this. So from there, I'm just gonna select my solar panel. I'm just gonna edit the family and say edit family. Go to the front elevation. So on my front elevation, I'm just going to select the whole thing, go to filter, check none, and then I'm going to select only my generic models, and then I'm going to say rotate. So from there, I'm just going to rotate it by let me make it 25 degrees, and then I'm just going to move it towards the top like this. So it's going to be placed like that. Go to the 3D view, and then I'm just going to select this extrusion, and then say go to materials. So as you can see, this is the monocrystalline solar cell. I'm just going to duplicate it, And then I'm gonna select this and then go to image, and then I downloaded this image of remember from our episode of the monocrystalline solar panel episode. So I'll leave the link in the description. So I'm gonna select this image and then apply it like this and say apply. Okay, so this is what we have, and the visualization is much more better. It's better now. So I'm gonna go to load into project. I'm not gonna save this, override the existing views, and then let me just change this to realistic. So this is basically what we have. Now it's time for us to apply our generative design. So for generative design, you're going to go to manage and say under generative design, you're going to say create study. So the basis of generative design in Revit is you have to create your own studies, or you can apply the studies that came with Autodesk itself. So you have different a set of situations. You have grid object placement, maximize window views, random family instance placement, randomize object placement, stepped grid object placement, three box massing. So for this instance, we're going to use the most basic one, which is the grid object placement. So the grid object placement basically has to do with X and Y. So you have your X and then you have your Y. So it's sort of like a grid system, if I can put it that way. So I'm going to select it. And then as you can see, this is what we have when it comes to that. So the first thing is we're going to name our study and say solar panel placement. And then for this instance, you have different methods. You have randomize, you have space evenly, you have optimize, you have like this. And for this instance, we're going to optimize this because I want to maximize. So I'm going to say optimize because I want to maximize the amount of space we have on our roofs so that we can get more power. uh, the more solar panels we have, the more power we generate when it comes to this building. So for our inputs, we have distance between objects position X. So position X. So think of it like this. You have your grid system. Let me just go to architecture. Let me just minimize this and then go to grid. So you have your grids. Let me just draw your random grids. And then go to study again. So you have your distance between object and position X, which is this one. So this is your position X basically. And then this is your position Y. And then your family obviously is going to be set on this position. So this is basically the logic behind these sets of constraints. So you can adjust them. You can set it from 1 until 3. You can set it also this one from 1 until 3. But I'm just going to leave it like this. So let me just leave it at 2, and then adjust this one and also make it 2. So I'm just going to check this. And then also we have the minimum distance from objects to wall in meters. So everything here on your studies is set in meters. So you have your minimum distance object to wall. So I'm just going to leave it like this at 1.25. So I'm just going to check it. And then this is why we managed to load in our family, and also why we created our room annotation. So the basis of our studies depends on the family we load in, and also the perimeter of our room that we have. So regardless whether you are working with a building, or whether you are working with a solar farm, or whether you are working with something else other than an architectural concept. What you have to produce is something that your study will detect as a room. So you have to use your room separator, and then you have to use your room tag. So if you have your solar farm that has an irregular shape, so uh, let me just type in DL for our detail line, and then let me just randomly draw an area. So think of this as your solar farm. So this is the entire area. You also have to go to your room separator, and then you have to apply them towards these boundaries, and then apply your room tag inside so that it can be detected when it comes to your study. So let me just remove this. I hope that makes sense. So for this instance, we're going to select our family, which is our solar panel, and then we're going to select your room, which is our room tag. And then you have your goals. You can set your goals, number of object place, minimize and maximize, object area overlaps, and then object area outside room, object area inside room, and then you can adjust your x distances and y distances. And then also you can set up your constraints manually, or you can also set up your constraints manually if you check these boxes, and then you can enter your variables after that. And then these, I'm just going to leave them like this because they become more tricky. So when it comes to your generation settings, you can set up your population size. So for this one, I'm just going to leave it like that. And then for your generations, which are basically your iterations, actually your population size is the number of options used to start the algorithm. So this is the number of iterations your study is going to produce. So for this instance is 20. I'm going to set it to 10, which automatically sets it to 8. And then your number of generations, round of iterations, increasing the number of rounds may improve results, but the study may take longer to complete. So generative design, you have to have like a powerful computer or CPU in order for you to generate great amounts of iteration for a large area. Because I remember I was working on a solar farm the previous year, whereby I have to do generative design on a large area for a solar farm, which was like 1 hectare in size. So I managed to generate like three iterations, but to complete the whole set of iterations took like 2 days. And in some instances, I had to abandon that task because it took so long. It took so long, and it took most of my time. So I had to like abandon that task. So for your generations, I think it's right at 10, and then your seed is the starting point of the algorithm, can be any number. So I'm just going to leave it at 1. So after this, this is what we have. So I think we can, so I think the only thing that's left is, as you can see, this is grayed out. So it says, please review and fix all existing issues to continue. So let's see what issues we have. The name of the study is already in use. So I'm just going to say solar panel placement -1. And then I'm just going to say generate. So it's going to generate your different configurations and iterations. So you just have to wait for it. So it's gonna be from it's 0/10. So we're gonna have to wait it until it gets to 10/10. But as you can see along, it generates your different iterations and configurations. So as you can see graphically, you can see how your solar panels would be arranged on your roof. So we're gonna go with this one. So we're gonna go with the fourth one and then select it. And as you can see, these are your different outputs and then your variables. And then you're gonna say create Revit elements, minimize this, and then you're gonna go to your 3D view. So on your 3D view, it's definitely obviously offset your solar panel. So I'm gonna select one. Let me just remove the original one, and then select one, right click, select all instances visible in view, and then I'm gonna change the offset from 4000 to 0. So these are your solar panels and how they are set on your roof. Now you can just go to your schedule and then say new schedule, and then you can say multi-category schedule, and then you're gonna type in type, and then this, okay, category goes first, and then type, and then you're gonna say your family, and then you're gonna say count. So we want to see the amount of solar panels we produce. So you're gonna say okay. And then for your walls, we don't want walls, so we are working with these generic models. So I'm going to go to field, sorting and grouping by category, by type, and then by family. And then I'm going to add these blank lines, these footings, and then title count totals, and then grand totals, and say okay. So let's say the amount of solar panels we produced. So we produced 93 of them actually. So this is the amount of solar panels we produce based on our generative design study. So I'm just gonna select one and then right click and then select all instances and then remove them. Go to level one again, select my component, place another one like this, and then I'm gonna say generative design. So let me just select the last one and say create Revit elements and then minimize this. So let's see the amount of solar panels we produce. So obviously they will clash because this depends on the constraints that I show you guys that you set on your studies. Because the distances between your elements, the distance between your elements depends on how you set them up on your inputs and also your goals and also your constraints. So yeah, let me just go to undo. So this is basically what we have based on what we said initially. So yeah, that is it. That's the basis of generative design, guys. I try to keep it as basic as I can because I'm also doing some R&D when it comes to this. I'm not very much polished when it comes to this topic, but yeah. So if you want to take it further, like I said, you can generate your own Dynamo scripts and also your Python scripts, which then feeds into this, and then you can set them up however you want. So thank you guys for watching, and I hope you guys enjoyed this episode. I try to keep it as short as I can, as I could, and I'll see you on the next tutorial. We're gonna be doing a pump station design. So I'll see you guys on that next tutorial. Peace.